So I'm actually going to address this question of this kind of an introduction. Hopefully you will have then lots of questions after that. But the way I'm approaching this now is that I would use as a specific example a big European project, which also Aalto is participating in, and then then expand from that to a somewhat kind of wider context. But maybe it's easier to grasp these questions when we think of us also that in terms of a specific project. So this AI Mind project is indeed a very large European project where the aim is to find intelligent digital tools for screening of brain connectivity and dementia risk estimation in people affected by mild cognitive impairment. And this is a 14 million euro project, and there are 8 countries, 15 partners, might be even more now, and there are the rationale for this project is that worldwide there are 50 million people affected with dementia. There's a very strong increase expected in the number of people with dementia. In Europe alone, 10 million people. So these are very large numbers and serious concerns for the individuals and their close ones, and of course the whole society through the cost and all the effect on the society. So this is an important question, and the focus in this particular project is on mild cognitive impairment and how that may change develop into dementia. So there's normal brain aging, there's dementia, and somewhere in between there is something that can be defined as mild cognitive impairment, which is a condition intermediate between normal brain aging and dementia. And there's an understanding that up to about half of the people with MCI are at risk of developing dementia within, say, 5 years. And the annual incidence of MCI ranges from 5 to 20% in people older than 60 years of age. And current clinical practice does not include screening for MCI, nor are there dedicated methods for discrimination of people who are prodromal to dementia. So, and then the goal of the AI Mind project is the plan is to collect, or much of this data has already been collected, EEG plus some MEG data from altogether 1,000 people in 4 different countries, so basically 250 people in each country, with people with MCI, and then also very extensive behavioral and clinical data from them. Follow these individuals for maximally up to 2 years, up to 4 sessions. And then the aim is to extract brain features of connectivity and spectral power. And then with these brain features, then try to train an AI tool or multiple tools actually to predict conversion from MCI to dementia. So that's the plan. And the ambition is that the patient journey would actually be shortened very strongly and be kind of easier and more straightforward. So there would be symptoms of early stage MCI. There would be a visit to the doctor, examination. There would be EEG collected, which is generally very widely available, which is an important thing, and the analysis. And this would be fed into the AI Mind connector, where the outcome would be an early identification of disturbance in the brain network. And then what we would further include are digitalized cognitive tests, genetic biomarkers, and that would then at the end, the AI Mind predictor would aim to make a fairly accurate estimation of dementia risk for clinical decision making, so that at the end, 1 week later, hopefully, there would be early risk estimation, there would be decision of further investigation, personalized report, recommendations on lifestyle changes. So that's the ambition. Now, of course, I think everybody can see that there are clearly ethical challenges in this kind of study. So, I mean, obviously, which I haven't even mentioned here, is that because it's so obvious that this is focusing, we're looking at humans. So, of course, we have those ethical challenges, but these are kind of, one would say, pretty well covered by current guidelines on medical and non-medical research. There are good guidelines on studies on humans, and many points have been already considered. But then now the special thing in this case is that now we have artificial intelligence, we have medical decision making, we also use neurotechnology. So in fact, we have a rather kind of flammable combination of things that indeed as a combination make this very something where you kind of immediately can see that there really, one has to consider the ethical aspects carefully. What makes it a bit difficult, well, not difficult, but at least a challenge also in the way that it's not just an ethical challenge, but also a challenge to think of what to evaluate, is that for many of these things, of course, medical decision-making is kind of a separate thing that goes to the clinical domain, but when we bring in artificial intelligence and neurotechnology, these are areas where we don't have, it's harder to, because the thing about ethical evaluation is that there need to be some sort of, of course, we have the overall ethical guidelines, which apply to everything. Like what is kind of proper ethical conduct in research. But then often the issue is then about how to bring this into the, say, grassroots level, how to say that how in this field, the questions I'm dealing with, what are the aspects I should consider? What are the aspects I should generally consider as a researcher? What are the aspects which might trigger ethical review? And what will the committees that do ethical review, what will they focus on? What should they focus on? Because they are never, there's really a kind of someone who's a full expert on everything, but more like there has to be some points which one has to consider. And this is often the difficulty. And also in this field, in these new fields, that what are the specific aspects how one does divide this into things which you should especially consider. And this is something which is very much in the discussion at this time, like also for artificial intelligence, neurotechnology. But let's hear it, because in this case, let's just accept that the question, especially of combining artificial intelligence with medical decision-making, is now our focus. So what should we focus on when we think about the ethical challenges? And here I just, there was a recent paper last year, which was actually seemed to be rather interesting in this regard, or helpful in at least I felt it was kind of helpful in thinking about these different aspects. And of course, there are many others, but now I chose this one as the kind of a bit of a basis for this discussion. So what they suggested is this kind of division that, well, the point is first that when we think of ethical AI, so in practice, it's very much something that is already referred to as a trustworthy AI. It's not exactly the same thing, but many of those things which are there in the trustworthy AI, they are ethical issues in many ways. So that may be a good approximation at this point. And factors that would affect trustworthy medical AI, they kind of suggested this kind of division, which to me made a lot of sense. And there's a question of how you design what you're doing. So then it's about the data, algorithm, and then you have the application questions, impact on human rights, who is responsible for AI. And then they divided this into kind of a little bit smaller boxes, specific questions about data acquisition, for example, data processing, data storage. And this is, of course, a question where, it's kind of this general thing we all know as researchers that when you put garbage in, you get garbage out. So in the data acquisition, that's an incredibly important thing in kind of making AI solutions trustworthy and thereby also presumably more ethical. that you really have to think carefully where the data comes from that is used for training a model. Is the proper standardization, or does it come from many different sources in many different forms? And then it comes to humans who decide what to do with that data, what to put in the model. So there's this very strong human component, which may add variability. Also, the data, of course, in itself should be representative of whatever is the goal of the model. So that's a really, really important thing, that if one wants to, well, obviously, if one wants to apply it in the kind of generally, well, if you want to apply it to even like to males and females, you shouldn't train the model only by using only males or only females, obviously. But this kind of general principle is very, very important. And then also there's the question of annotation of the data, whether it's first of all whether it's going to pre-processed similarly, and then if it's how the annotation is done, and what if there are some decisions in the annotation which actually will vary between the kind of sources you put in, and or if you don't really make good notes of what the logic was of the annotation, because then you are not able to really go back and correct that if there were some issues and biases. And so the human input is there. It's a big thing. And of course, data storage in general, there are also it's both a GDPR issue and it's an ethics issue as well. And there is the question of the ownership of data as well, which may then cause unexpected problems later on. Then, of course, algorithm, that has been often talked about quite a bit. So clearly there can be just plain flaws in the algorithm, and it may be heavily biased in ways that then will influence everything afterwards and just keep kind of enhanced, reinforced, and amplified when there's more further improvements or changes, or well, not improvements but developments of the algorithm. Also, there's the question of the algorithm being a black box, which is particularly the case for deep learning, that it's really even difficult to understand what the algorithm is actually doing. It may produce really great results, but it remains unclear where it comes from. So it's also hard to detect things. It's harder to detect the biases, and it's also harder to maybe to observe kind of harder to predict the kind of let's say unexpected situations, because then you don't understand the algorithm itself so well. So there is and this bias question is particularly important, of course, because there's the human-induced biases and there are data-induced biases. So the human who is developing the algorithm may have biases which actually come through. They don't even recognize that. But when they are setting up the algorithm, something is already kind of they introduced bias in the algorithm already. And then there is this question of data. If the data itself is not, there is bias which wasn't even thought about possibly. So there are those issues, and of course there may be just plain errors, and there may be vulnerabilities. So there may be things happening that when people thought that this is working in a certain way, and for a long time it works in a certain way, then there is something sudden which some unexpected performance that was which really unexpected performance from the algorithm. And then from the application side, and of course there's also the question of in general the inability to explain the algorithm, and which goes to the black box part, that there's inability to explain it in a way that people can understand, or most people who are not trained in this field could understand. And so that's one important issue as well. Then there is the impact on human rights, which is also actually links to the data largely as well. That there's in general the question of autonomy, that people have a feeling that they have a control over their own specific situations and their choices, and that it's not some sort of that they don't hear the claim that, well, the computer knows best kind of thing. And that's a privacy issue, which goes with the data processing. So people's data is used for training the models. Then it's used it's applied to say, treating these individuals. So there's the general question of patient safety, privacy, also because indeed people's information is already in the models, to how to make sure that there is no unintended unintended release of sensitive personal data. And yes, and yeah, well, maybe that's kind of it for now. I think there's still So for the autonomy, there's also the question of individuals' values and preferences, which is very hard to build into any AI, and of course they shouldn't be. So that brings us to also who is responsible for decisions made based on AI. The question of how far it's the AI which is responsible, where the human responsibility starts, and I think especially in this taking into account the individual values and preferences of the patient or the person is applied to, that this is something that it's very hard. I don't think it's possible necessarily to even bring in AI. So there really a human intervention is important to interpret what AI is doing and then making the decisions. And also one thing which is probably the responsibility question, which is perhaps it's a partly philosophical question, but generally I think there's general feeling that even if the AI is not sufficiently interpretable, there's not it's not necessary or sufficient that the interpretability is not sufficient or necessary for accountability. So even if the person who's using AI wouldn't understand all the details, nonetheless, if they're making decisions based on that, they are responsible for those decisions. Okay, so these are general questions. And then I was wondering, how does our AI mind project, what are the specific questions we have been discussing there? How do they align with this general view? And I thought, yes, we have discussed very much the informed consent, obviously. There has to be very much the really detailed information to participants so that they know how their data is going to be used. Obviously, the question of confidentiality and secure processing of data is key in this kind of studies. And we really have been discussing a lot about that the model has to be non-discriminatory. So at this stage, the people who have been collected, the data which has been collected, these are white people from Western countries. So this is not going to be a very widely usable thing, but this is understood. So it's understood that this is how this starts now. But if we can get it running, then really clearly the model will have to be expanded, or there will have these separate models for different areas, whatever. But it has to be. This is understood. And there's a lot of discussion about the transparency of methods. So at least thinking of how the reports, for example, would have to be prepared so that there is some understanding. So that first there are this kind of descriptions, try to be a simple description cards of the methods and tools, so that there's a chance that people using this might somehow at least understand what's in there. And then also the reports would be in such a form that it's useful for a physician, that it's kind of like they get a bit of where this comes from, and not just that, it's none, but it's 9 out of 10 or something. And then, of course, this respect of individual autonomy is very much recognized, and that there has to be non-discriminatory treatment, so that this should be very much available to everybody. It should be something that wouldn't require terribly expensive machinery or wouldn't be very costly. So in principle, that should also help, that everybody should have access. And in the end, everybody should be able to have access to, if this works well, everywhere in the world. And there should be a fair and just access to methods and results, which of course in general is important in science. And there's a very strong understanding that humans must be responsible for conclusions. So what comes out of AI mind can only be a report, which then is interpreted by the doctor and kind of thought about, and also using other information. So this should just be ideally, not just, but should ideally be a very, very informative, good summary of lots of data in a way which is impossible maybe to analyze to such degree at once by a human. Okay, so then the question of what should be then evaluated, for example, how should one think about what are the aspects? These are, of course, the kind of these detailed lists, but then these authors, I thought they did a nice job in thinking of how could they summarize these different things into a smaller number of topics or themes which need to be considered. And I thought I pretty much agreed with them with this one, that certainly one of them is data quality overall. One is clearly algorithmic bias. One is the opacity of the methods, or then on the other hand, how transparent they are. And then the question of general of safety and security, so you can see that there are links to many of these different parts because they do come together. So, for example, safety and security, it's not just the algorithm, but it's also about the autonomy, privacy, data acquisition, data storage things. And then there's the question of responsibility attribution. And then I was thinking that, okay, so this is interesting, but how does this link to, so we do have these big principles of basic things about for example, European Code of Conduct for Research Integrity, very general, very valid viewpoints into this. So basically, of course, research ethics, it's in a very simple way, it's honesty and respect towards your study subjects, colleagues, and society. And this is kind of expressed in this European Code of Conduct in this way, that there's a kind of reliability, which relates to the design, methodology, analysis, etc. There's honesty, open, fair research and reporting. There's respect, research participants, colleagues, society, etc. And then accountability, which should be considered for the entire life cycle of research, from idea to impact. And now I was thinking that, well, okay, so if we have in this AI in medicine, we have, for example, these 5 main themes of data quality, algorithm bias, opacity, safety, security, responsibility, attribution. Can I kind of, in a way, link these to the European Code of Conduct principles? And I think yes, because data quality, it certainly links to the questions of reliability, of design, methodology, analysis, certainly with respect towards the participants, and also I think towards society. I mean, of course, colleagues and society, but society also in quite a big sense that we kind of try to do this so that it's that there are generally valid and proper models, and accountability, because this is now really it affects the entire life cycle research. Algorithmic bias, that has to do with reliability, honesty, respect, and actually so does this opacity. It has a lot to do with how reliability is viewed in this case, how honest it is, that we show respect towards other people and the society. And then there's safety and security, which again links to reliability, respect, clearly, that we handle the data properly, and accountability for the life cycle. And responsibility attribution, it links probably a bit more to this respect and accountability parts. So in the end, I think there's quite the big principles still apply. It's just worded a bit differently because we are thinking of a specific field. And then when we have worded this differently and thought about what are the specific things in this kind of context, then we may think of that if these situations trigger ethical review, and of course in this case they always would, because it's AI and it's medical decision making. So definitely there would be ethical review. So then the general rules of ethical review apply again, which is you consider risks and their mitigation versus general benefit that can be obtained, and this is the balance which one has to weigh and consider. And then there's always the issue of that is if there are people involved, humans involved, informed consent of research participants. And then the big issue of data management in general. So these are typical things which are considered, and I think it applies here as well. So yeah, I think that's what I wanted to say now as a basis for this.
Excellent.